All right, not bad, but I'm sorry, Abzu. Your boss fight is just not as epic as the Airbuster, both in combat and in music. Tough break, guy. Aha! Ding ding, that's the last one! Everybody is here. Perfect. Then, let's get started. Good morning, everybody. How are you doing? Let me get the right view on my screen. All right. Today we're gearing up for something new, and that is rational exponents. Okay? We had quadratics. We did quite a lot of study on that. And then we said, but what if the power is more than 2? What do you do now, right? Polynomials. We can all kinds of crazy things. Except the exponent was always a positive integer. So next we want to ask the question, what happens if the exponent is a rational number? That is to say, some kind of fraction, right? Something not an integer, usually less than 1 is typically the most interesting, but you could have any kind of fraction. You could have 1/2, you could have 4/3, right? Any rational number there. This, of course, does technically include the integers, so whatever our results, it has to be general enough that it still does apply to a polynomial function. But we're getting ahead of ourselves. For today, as well as tomorrow, so this whole week, we are preparing for rational functions, and that is to say, hey, remember how roots worked? And this is totally not a spoiler at all, right? This is definitely not exactly what numbers to a rational exponent actually are. But for the sake of practice, before we get into that new thing, let's review the old thing and make sure we are well-versed, well-equipped, and that this is not going to be a stumbling block for us forward. Can we find the square root, cube root, fourth root of different numbers and expressions? Okay? So on your worksheet for today, I like these study guide intervention sheets because they include all the notes right there on the page, right? Doesn't get more efficient than that. So reminder, square root by definition is, right, some number that if squared equals the thing you're looking for, right? So it's kind of a work backwards. When presented with root of something, you are asking a question. What number, when raised to the index power here, gives me that, right? And we can generalize square root into nth root, okay? So when we have a little spot to write in here, right? Some nth root of x, that little n, we call that the index, okay? So when you're talking about the nth root of something, that's your index. And then the number underneath and with the radical there, we call that the radicand, although nobody uses that word like ever. So just know if it does come up, that's what they're referring to, is kind of like a dividend and divisor, right? You have numbers or have words to point to all these specific positions in the expression. That's what we've got going on here, right? This guy is the radicand, this is the index, and of course the funky squiggle line heart monitor beep itself is the radical. Okay, so that out of the way, look at the technique here. And I'm going to go a little more general. You could follow this step-by-step process. I think it's a little bit too wordy. So follow me through these examples, and I'll give you a kind of my shortcut, how I think of it in my head. Right? And what we're looking for is always check the index first. What group size are we looking for? If there is no number, an invisible index is always a 2. Okay, so this is secretly the square root, okay, 2 root the second root of 49z to the 8th. And what this tells me is I need to factor this into groups of 2. When I see a pair there, right, that matches my index, I can pull that out of the radical. So is there a matching pair that multiplies to give me 49? Yes, it is. It is 7. Okay? And I know they've written it all as one group there, but I would go one step at a time. Focus on the number and then each variable as you go, one step at a time. So factor that guy down. That gives me 7. Right? So these x's are in fact 7s. So let's get to a different color. Right? So these guys are 7s. So I have a group of 2 matching my index, so I can pull one of them out in front. And now let's look at that z to the 8th. Can I write z to the 8th? Can that factor into 2 things? And yes, it can. 2 equal things, right, would be z to the 4th times z to the 4th. You need to know your rules of exponents, right? Because all of that applies here. So I have a matching pair. I can pull that out. And if you wanted to, if you don't see these right away, go ahead and break everything down as far as it'll go. Just factor tree the heck out of this. This is z and z to the 7. And this is z and then z to the 6. And then find matching pairs. I found one pair there. Okay, that's one z I can pull in front, right? And then you keep going. Let's say maybe I get it now when I see z to the 6. I'm like, oh, okay, so there's a matching pair. Pull that up front. What are we left with? We got 7 in front. We got z in front. We got z to the 3rd in front. What's left in the radical? Nothing. Get rid of it. Right? Oh, okay. Power 1 plus 3, 7, z to the 4th. Okay? Really terrible 4. That's better. So that's what you're looking to do. I know it seems a little odd working that example that way, but it does model the process well, right? As soon as you do see something, right? This one seems obvious to you. Okay, not everybody sees that right away. Some numbers, right? This is where knowing your squares and your cubes really comes in handy. Because look at the other example. Ooh, I want the negative cube root of all this. Oh no, what am I going to do about that? Give myself some space here. Well, since the index is 3, I'm looking to split this up into groups of 3. And that's what they've done here. They said, hey, 2a minus 1 squared can be cubed. I can have 3 groups of that. All right? So either break it down in the tree and look for 1, 2, 3 things there. Guess I can write that, right? 1, 2, 3. And then match those, pull those in front. And, or if you can rewrite it with that exponent, as long as those are a match, I can take this and put it in front with no exponent. When there's nothing left inside the radical, don't leave it there. But I'm anticipating things like, what if you had, let's double 49. What if you have 98, right? Square root of 98. Well, that's 2 times 49, right? And if I have the square root of a product, that's equal to the square root of 2 times the square root of 49. Okay? Your radicals can be broken up just like so. And so that one I know, oh, that's 7 times the square root of 2. 2 stays inside. Or we can think of it as I often do. 49 breaks into 2 7s. I need pairs. So here's a pair of 7s. Put the 7s up front. Leave the 2 inside. 7 in front. 2 stays in the radical. 7 root 2. Right? However you want to think about it. There's different approaches to this, okay, depending on what makes more sense based on implementation. Now, they do have this negative sign here. Don't let that throw you off, okay? Because that just means this, you want the negative of the cube root of all this. So we should end up with a negative value there. And that's where these listed rules come in. Right? If b is less than 0, I like that, right? B, that is to say, the radicand inside the radical, if that is negative, right, then you can get positive or negative roots. But of course, every even pair, right, when n is even, you get no real roots, right? There is no way to combine an even number of negative numbers, right? Negative 2 times negative 2, oh, that turned into positive 4, right? You can't get a negative result, okay? So that's really all your check here is to say, if this is negative, this better be odd, okay? Is there a negative third root? And yes, there is. We can make that work, okay? It doesn't mean your answer is necessarily negative, especially when it's an expression like this, right? This thing ends up squared, so this part will always be positive. So you've got kind of an exception there. Don't let the negative throw you off. You can end up with a negative number, but not necessarily a negative expression as your answer. Hope that makes sense. Okay, any questions there? No? All right, this should be review from Algebra 1. And then the next part to this would be approximating radicals with your calculator. So this is all numeric. Okay, you should be able to do this. The square roots, I think everybody can find the square root button on their calculator. But what if you have like a fifth root button? There's no fifth root button on the calculator. Not exactly. So what you need to do, and I've written out the button sequence for this example here. It's hidden under the math menu. And just a reminder here, okay, the math button here, hit right there, okay, underneath the alpha key. So that's the menu you are looking for. Okay, so you'll press the number for your index first, right? Because notice the listed number 5 on the math menu. So index first. Math menu button. Entry number 5 is the little x radical. And so because that x comes in front of the radical, it's going to draw from the number in front of it. And then you type in your radicand, your number 18.2, enter to get the answer. All right? And looks like they're asking for 3 decimal places rounding here. So very straightforward, just a little quick calculator practice. This half of it, these 18 questions should take you like 3 minutes or something, something ridiculously small like that. Okay, it's just button mashing. The word problems, though, that's where like some actual thought may be required. So work your way through those. All right. Any questions then on any of this? Simplifying the radicals or approximating with a calculator? well, then I'm going to leave you the rest of the period to work. Chime in if you do encounter any trouble. Before I end the YouTube stream, though, quick reminder, there is a video I made yesterday about the end of the year, final opportunities, extra credit, how to bring up your grade, all that useful information. Please, please, please check that out if you haven't already. It's a short video. All the information is there in the video description if you want to read through it. But understand that and how your grade will be affected going forward. Okay? With that, we'll end the stream here.